please open your textbooks up to page chapter 9. Page 395, please. Page 395. Today we are going to take this a step farther, like I asked you to, and we're going to think about how we learn to write and think about relationships a little bit more carefully, because today we are going to take these patterns, we're going to see how they're related, and then what is the next step we're going to do? We're going to turn them into line graphs, and we're going to be able to see patterns in our table and in our line graphs, okay? So what I'd like you to do is read this, please, with your neighbor, and we'll see how we can fill in this table. Go ahead, please, carefully, and do that.
I'm starting to use this on you start to give them rules.
What are you working on? That doesn't make sense. Oh, I guess Andy's gone. That's fine for now. It just doesn't make much sense. So guys, this is a real life example, right? We saw yesterday how often food and recipe and batches can follow these patterns. What are they making in this recipe? Hot cocoa. What's another word for hot cocoa for those of you who don't know that? Hot chocolate. How many of you have ever had hot chocolate with marshmallows in the winter? It's good, right? So they notice that two things are connected. The amount of cocoa mix you use and the amount of, Reynaldo? Water. If you put the wrong amount in, maybe your hot chocolate will be too chocolatey or too watery. You have to have just the right balance. Yeah? All right. So what does it say here in this problem that helped them start this data table?
It says in the problem.
Yeah, what do they say in the problem that helped them start this data table?
It says 3 tablespoons of cocoa.
Good, so please make sure you circle that within your problem. For every 3 tablespoons of mix, what does he have to use in order to keep this the right taste?
6 fluid ounces of hot water.
Fluid ounces of hot water. These two things are connected. You and your neighbor right now, I want you to take a look at this and see how these two things are connected. Before we were writing the rule, you can take a look at your worksheet if you need to, but I want you to talk about the rule. How is this cocoa mix connected to the water? Just the way we did. Go ahead. I want to hear your voice. Look at your worksheet if you want. How is this cocoa mix connected to the water? This is how I started each time. Amount. So try that.
So now I'll look up cocoa mix
Cocoa mix.
with the amount of cocoa
You're not combining those two things. You're looking at the relationship. How are they connected? Here we said the amount of money spent is 35 times the number of months. Meaning for every month, he's going to spend $35. What about here? What above? Cocoa mix. You're not mixing it with. No. Can you help him out, please?
The amount of cocoa is times the
Is it?
The amount of
3 times bigger than
cocoa
this?
mix is
6 times bigger than that?
is
Yes.
the amount of water is 3 times the number
It's times 6? No.
is 2 times.
Who came up with the answer? Who came up with the answer? How are these two things connected? Listen to the way, Gabriel, you start.
I said 3 times 3 equals 6.
3 times 3 equals 6?
3 times 3.
Is that the way we were saying the rule before? Everybody take a look at your worksheet. This is not very good. We need to use proper mathematical language. How did we start each rule on the worksheet below?
The amount.
The amount. We are comparing these two amounts. How do these two amounts compare?
The amount of cocoa mix is 2 times the number of water.
Is it? Is this 2 times the amount of water?
No.
I think you're on the right track. Is the cocoa mix 2 times the water? What mistake did Arlette make? Benjamin?
Instead of saying the water is 2 times the cocoa mix, she said that the cocoa mix is 2 times the
Right. The water is the bigger one, right? So the water is 2 times as much as the cocoa mix. How do you know that? Because take a look here. Times 2. Yes?
Yes.
Some of you are trying to combine the mix and the water. That doesn't make much sense. The rule needs to work for each one, so let's make sure it does. All right, he's making 1 batch of cocoa mix. Yeah? What if he wants to make 2 batches of cocoa mix? How much cocoa mix will he use? 6 potatoes? Because picture it, 3 tablespoons for 1 batch, 3 tablespoons for another batch. Let's keep going. 3 batches. 9 tablespoons. 4 batches, Juliana. Can't hear you. 12 tablespoons. They gave a little break in the chart like we saw yesterday. Now let's think about the water. 3 tablespoons of cocoa mix for 6 ounces of water. What about another batch? I want a hand that I haven't heard from today. Lisana?
12 water
How do we measure water? Fluid ounces of water. Because 6 for one, 6 for another make 12. 18 and... Can't hear you? 24. Let's see if our rule works the whole way through. Think back to our rule. What did you say that the rule was, Benjamin?
I said that the rule is the amount of water.
Good. The amount of water
is 2 times the amount of cocoa mix.
is 2 times the amount of cocoa mix. Does that work here? Is the amount of water
Yes.
2 times the amount of cocoa mix?
Yes.
Let's see. Is 6 times 2 12?
Yes.
Do you understand why this rule works the whole way through?
Yes.
Listen, this is going to be very smart, I can tell. Half of the water. Because half would be, what's the opposite of multiplication? Everybody? Division. And isn't dividing by 2 the same thing as a half?
Yes.
When you flip it, what do we call it when you flip it? The reciprocal, right? So 1/2 of this could be another way you say that. Very good point. Let's continue. In order to figure out how much water we have here, can somebody please tell me what I need to do? Let's use our good mathematical. The water is twice the amount of cocoa mix. So let's multiply it times 2. Everybody do that and see what you get. version. What'd you get there, Donovan?
36.
36, very good. Because these two things are related, so that's the easy part. That's what we did yesterday. We're just using better mathematical language to describe these two things, and we'll keep working at that. The new thing we're doing today is because those two patterns are connected, Osvaldo, we can use them together as ordered pairs and think about their connection using a line graph. What does this 3 stand for here? The x coordinate. Where in your data table did that come from? Good. When you use 3 tablespoons of cocoa mix, you use 6 fluid ounces of water. Let's keep going. Do you see where they got this from?
Yes.
When they use
6
what?
cocoa mix, tablespoons.
At tablespoons of cocoa mix, they use, Ari? Good. Keep going, please, to fill the rest of these in. You can look up and see if that's what you got. They want us to write the rule in here. See if you and your neighbor can remember the rule real quick. Go ahead. Thank you. What's the rule? The amount of what? Is 2 times the amount of good. It's twice as much, right? You're going to use twice as much water than you do cocoa mix. All the way up to here, twice as much, double, right? So the rule is, just like we said, multiply water, ounces, by 2 to get the cocoa mix. Which is what we talked about. It's twice as much. So let's see how we could also understand this pattern using this coordinate plane. Can you please show me what the x-axis looks like? Please show me what the x-axis looks like. I'm waiting for a couple kids. Sergio, that means you. Stop. The x-axis, what data did they put on the x-axis, Louis? The cocoa mix, the tablespoons of cocoa mix. What did they put on the y-axis? The fluid ounces of water, right? The ounces of water, not the water of fluid ounces. These two things are connected so they can graph this data. Let's do that. We just made coordinate pairs. I'll do the first one with you and then you can do the rest with your neighbor. The first one, what direction am I going to go in first? The x-axis. So over how many on the x-axis? Positive 3. And then up 1, 2, 3, 4, 5, 6. This person chose a scale and an interval of 3s. Yes?
Yes.
It's an even scale and interval. Go ahead and connect, please, or plot the rest of the ordered pairs. You and your neighbor can check in with each other. I'm going to be checking in with someone, please. Check in with Aaron. You need to get in this group.
9.
How you doing back here? I did not ask you to do that yet. No, I did not ask you to do that yet. I did not ask you to do this before. 18, we don't have 18 yet. But after you're finished, 6, 12, 9, 18, 12, 24, thank you. And we don't have 15. Now, after I asked you, I want you to connect these starting with 0. Why can I start with 0? Because if you have 0 cocoa mix, how much water do you think you're gonna have? If you have 0 tablespoons of cocoa mix, Benjamin, how much water do you think you'll have? 0. You won't have anything, right? Just put it on the side.
That's it?
Who?
One more?
No, you can just put it on the side. I'll take care of it, please.
Thank you.
Last but not least, we're gonna graph our last number of data. Wait a second. Some of you already graphed that in. How could I have used this graph though without filling in this data table with math to know where that 18 goes? Let's fill in the 18 first. We know with 18 tablespoons of cocoa mix, how much water will I need? JL? 36 ounces. How could you tell that that's where that would be? Do you notice anything about this line graph?
Yes.
Tell your neighbor what you notice about this line graph. Jay, I need you to be with it, please, and do what I asked you to do. Have you answered what I'm asking you to answer?
I think
my question?
What I noticed is that it's increasing.
No, I'm asking you what you notice about the way this line graph looks. Listen to my question. What do you notice about the way this line graph looks, Ragda? Very good. Each time it's increasing. Let's see how much it's increasing by. 0 to 6. What do you notice there? It's increasing by 6 tablespoons. What about here? From 6 to 12. Yes? 6 tablespoons. This is increasing at what we call a constant rate. We saw an example this morning of a plant that grew a lot one week and a little the next week. That's not constant. These two are constant because the rule is the same each time. Okay? Do you have any questions about this? Analyzing data is a hard thing, but you need to make sure you're thinking first about the relationship, not however you want, with a rule that makes sense for everything, and then you can see with your graphing how that also makes sense. If we were to do 15, it would go perfectly there. Let's see if that works. 15 tablespoons, make a prediction. How many fluid ounces? And why does that make sense? Because the number of water, like we said, is twice as much as the tablespoons. We could have known that, and our graph affirms that as well. So we're gonna get working on our own for a bit. I want you to listen to my instructions. Analyzing data is hard, but you need to make sure you think about the relationship between those two things in order to graph today. My instructions are for you to independently do page 397, which is the easier part. When you're finished, I'm going to put you into some groups to do a challenge problem where you're thinking more about what that data means. Does anybody have any questions? I'm going to come by after questions 1 and 2. Please raise your hand to see who can continue working alone and who needs a little bit more help. Please do exactly what we did. Make sure the rule is clear and be ready to talk to me about it. Any questions? Okay, go ahead quietly and get to work on number 1 and 2 and then raise your hand. Do it the way we practiced today, not a new way that you're making up. Yes?
So we put that here, like,
Sorry?
that roll, do we put it here or?
Yeah, you can roll. This is the roll, right? Is that the way we did it today? No. You're not looking at how these two things are connected. How are those two things connected? Because here, does it go up by 1?
No, up 2.
So that's not a pattern then. A rule has to work every single time. Think about how these are connected, all of them. What?
The 2.
What 2?
The
weight. Very good.
Ounces and the
Butter.
tablespoons are all connected just because the weight ounces are bigger than
So what operations give me a bigger amount?
multiplication.
Put it on the side. See what one works. Every single time it has to work. That's not the way we did it today. No. One more pause. Stop, listen. Today, we are not seeing how this sequence goes alone. Sure, I could treat butter alone, Jay. Did we do that today?
No.
How did we do this today? What were we looking at? We were looking at how these two patterns, how these two sequences were connected. So if you're just looking at butter alone and then weight alone, that's not doing the right thing. Make sure you're doing it the way we did today by seeing how these two patterns are connected. Go ahead. So what did you pick?
Adding.
What are you going to add to get from this to this?
1 to 3.
And that works the whole time?
No.
So that's not the rule. What is the rule then?
Multiplication.
Multiplying what?
Multiplying 2.
What times 2?
Or the butter.
The tablespoons of butter.
The tablespoons of butter and
Times
the weight.
times what?
Width.
No, times what? What did you just say you were multiplying by?
Multiplying by 2
To get?
to weight up.
It's like you do something to get there. I'm multiplying the butter tablespoons times,
The weight.
no, not the weight,
So-
times 2. To get the,
Wait.
does that work here?
Yes.
The number of tablespoons of butter is
2.
times
2.
to get the weight
The weight
of 4 ounces. Come on, you gotta think about what we talked about today. Remember we connected it with 0? We connected it with 0 because if there was no hours, how much would she have walked?
0.
No hours, right? And this goes constant rate up by how many? Times 3, right? It shows a constant rate of 3. Multiply the distance, the hour, times 3 to get the distance. That way you can make a prediction in the future, yes?
Yeah.
Which is what you're going to do next, so continue. Go ahead, arrange your table and correct. Make sure their things are plotted appropriately. This isn't very neat. I can't tell where your coordinate point is. You connect it with 0, which I like. Please make sure their graph is neat and that they're looking at the relationship between these two things, okay? Go ahead. Good, and you can use this to make predictions in the future, right? Make sure their coordinates are neatly plotted. They're ordered pairs. Where are your labels here? Go ahead and correct. Type 12, I noticed something. Sorry to interrupt you again. What's missing from this line plot? The title at the top. Is that what you mean? The labels for each axis. What is being shown down here and what is being shown here? If you don't have that, you're not ready to go on. If she's not ready, don't wait for her. Keep moving. This is the weight. 1 ounce for 2 tablespoons of butter. Something went wrong. 1 of what is 2 of the other? 1 of weight? No. 1 of the tablespoons of butter makes 2 ounces. This is twice as big as that. You need to switch these. Going. We have the same issue. The weight is not 1 when the butter tablespoons are 2. What's 1?
1 is butter.
The tablespoons of butter. 1 tablespoon of butter times 2 gives you the weight. Is that what you have here? 1, look, you have the weight as 1. Your axes don't make sense. What goes on the bottom? The x-axis.
1 goes in.
1. What does 1 belong with? What unit?
It goes to the bottom.
Is that what you have? That means it's not graphed correctly. You're forgetting a label here. Tablespoons. We need to know how to measure our butter. Look at this. Doesn't this make sense? For every 1 centiliter, there's 10 milliliters. You know that there's 10 milli in a centit. Put into this one too. Why? On a map. Do you really see miles on a map? Did they give you that little thing called a scale to show you? So you know what each one of those means, right? You've seen that. Okay. When you're done with number 4, please raise your hand and I'll give you your bonus worksheet. I'm going to work in some partners with that one. Did you check everybody's? Okay, so you two are ready to go into the bonus. This one's an interesting one. Read it carefully, and it's asking you to analyze this data. Think about it carefully. Not just making a graph, but to do something with it. Did you fix yours? 1 hour. How am I measuring time here? There's a lot of ways to measure time. So tell me what the rule is in your own words here.
The rule is times 3.
So put it in your own words. For every, the amount of
The amount of distance she's walking times 3 of a mile.
It's 3 of a mile? No, because that means you're just looking at that. The distance that she walked is how many times? 3 times the hours that she walked. Continue on. Wait for a second, actually. 1. We need to connect this with 0, please. When you're finished, you and Ragda can work on this. Violet, I want to hear your voice, you and Evelise. You haven't labeled yours. Once she labeled hers, you can check it, and the two of you can go over this graph sense together. You can sit over here next door. You need to keep track of your things, so this can't be everywhere. No, you're fine. Sit down. You come next door, and you work together on this bonus problem. Can you please check Omar's, and then you two can work on this bonus problem? Check Louise, and you can work on this bonus problem. Please check Gabriel's, and then you two can work on this bonus problem. Where are your labels? What is this axis? You need to connect yours with 0, please. In addition, I see a little error. Oh no, you're good. Correct it with 0, please. When you're finished, check Louise, and then you should come and learn to this bonus problem. Donovan, why don't you come sit next to them, please? No. Wait for her, and then you can work on that together. When she's done labeling her axes, then you can check hers, and then you can do that together. Okay? You guys can move on. You and Donovan, check Donovan's first. Check Osvaldo's, and then you can move on. That looks kind of messy. It needs to be connected neatly. Nui, you have an issue? I gave Steven one. Did I give you one to give to her when she's finished? When you checked it? Okay, come get one. Note that line graph looks way too messy, and it's not connected to 0 the way it should be. Those lines need to be straight so you can see the relationship and how it's going up, increasing, Brian, constantly, not all over the place like we've seen, right? There's none that grow more than others. They grow at a constant rate.
Yeah. Eleni.
So what happened to this line? Can you fix it, please? Who are you working with? When Sierra's done, you can check hers after you fix your line, and you can go on to the more difficult one.
Box of lemonade mix and use 2 tablespoons of the mix for each glass of lemonade.
We're only finished with the first 2. Keep going.
Eleni has 16 tablespoons and uses 2 spoons.
On to the next 2. Or you can read this and wait for Benjamin to check his, and then you can work together, okay?
Tablespoon box of lemonade mix. He likes his lemonade stronger, and uses 3 tablespoons of mix for each glass of lemonade. Who around first, Eleni or Sandy?
Twice as much, right? Or 3 times as much, I'm sorry. For here, it's how much is much. For every the butter there's 1 butter, right? 4 tablespoons of butter. All right.
And then
Hold on to this. Come over here, please.
columns as needed.
With your paper. Makes sense, right? Work on this. This is a hard one.
Oh yeah,
I can tell. Wait, stop. This is a good learning point. I can tell that this is not correct because it doesn't look like
It
it's
says
growing at a
lemonade mixed
constant rate.
tablespoon
Does it?
and lemonade.
It needs to be going up by the same amount. So see where you went wrong.
16 tablespoons.
He's almost
and
finished. When he is, you can pull up a chair and work together on this. Mochi right there.
So here, let's put 1, 2.
Why did you do that? I asked you to go get your other paper, by the way. So go get your other paper while he explains to me what to do. I put it over there. You weren't wrong. Why did you do that, though?
In the bowl, I did just set it and zero the number of glasses. So
You're using what?
2 tablespoons of
A mix for.
each glass.
So this whole pattern is based off the number of glasses you make. Do the number of glasses go up by 3s? No, for each glass. So you're going to look at each glass at a time. That's why you did that, right? I asked Ronaldo to give that to you when he was done. Did you check his like I asked you to?
Yeah,
No. Please do it now, and then you can work on this together.
The right graph is related number of pairs of order pairs label your graph. And then we 16 tablespoons back of mix as 2 tablespoons of mix of each glass.
Is this the way we were doing it today? No, we're looking at how they're connected. So that doesn't work. Don't go backwards. If you're just looking at this sequence alone, Louis, you're not listening. If you're just looking at this sequence alone, you can do that. But is this sequence alone? It has partners. So think about it. For each glass, you're right, so you're going to have to treat them separately. Is lemonade mix connected for Elaine, connected to the lemonade mix for Sandy? They are? They depend on one another, or they're separate? Good question. What are connected? What depend on one another? The glasses are connected to what? These two are connected because her mix depends on, the glasses depends on the mix. Are those the only things connected? What else is collected? So you have 2 things that are connected. Wait a second. How many line graphs are you going to end up with then? We just said all of that. Why are you then going to say 1? Explain to him, please, why you think you're going to end up with 2. Listen, I'll be back over to understand. Before you get started, this is all over the place. Do we just make line graphs with whatever we want? We make line graphs with what depends on one another, with sequences that are related. Have you made ordered pairs yet? So you need to first figure out what 2 things are connected before you start graphing. All right, now that we're all on this, listen very carefully for a second. You have to think very carefully for this, and we'll continue to work on this in the future. This has 3 parts, right? Now I'm thinking, and what some of you were smart enough to realize, is if there were 3 parts, that means you have 3 sequences. You need to think of all 3 of these sequences are the same. Are they connected in some way? Or are there some that don't connect? In addition, Jay, in order to plot these on the line graph, 3? Are there 3 coordinates? There's an x coordinate and a So you're gonna have to think about what's going on here. What will help you is to think about which of these patterns, which of these sequences are connected. We're gonna work on a few more minutes and then we'll come back to this tomorrow. Go ahead. You need to fill in the rest of this.
So the starting point for
What's going on? Well, I mean, this doesn't make sense. No. You don't start at the end, you start at the beginning. What do you know? For a glass of lemonade mix, what does she use? You have it circled or underlined, let's go. Don't make up a new way of doing this, especially in a complicated problem.
she for one number.
Wait a second. She uses, what? Omar, how much does she use? 3 what? What does this 3 mean? 3 what? What? Tablespoons of lemonade mix. Right? And then for 2 glasses? And why did you stop at 18?
Because it says that she uses 8 tablespoons. That she
8?
has an 18 tablespoons.
I see no circles or underlines or anything. So you stopped at 18 because that's when he runs out? Yeah? Take a look at him. Don't start at the end, start at the beginning and see what you know you're going to stop at 16.
I don't understand her name. I don't understand her name.
Elaine.
Elaine. She starts at 16 and
You're not reading the directions. Again, this is last. Use your graph to decide. You haven't graphed. So before you do anything else, you need to think about which 2 are connected and which aren't connected. We can't have a 3-point coordinate. This makes no sense. This makes no sense. This one makes sense. She uses how much? 3 what? You're not listening.
lemonade mix.
Tablespoons of lemonade mix. It says right here. So she uses 3 for 2 glasses? I'm sorry, nope. Go back and reread. You're not reading your facts carefully, so this whole thing's not going to go right. Does she use 3 tablespoons of lemonade mix for 2 glasses of lemonade?
No. I think we should do this.
Why?
This and that, and then leave one.
I think you're just saying things. Will you go explain it to him? I'll come back. Edwin and Lewis, I'm coming back for you. Why are you doing 2? Hold on, let Edwin, because I think you had an idea. So let's see if he did it. Not 2 tablespoons, sorry. 2, what are these called? Line graphs.
This is what I was trying to tell you. See, 5 is up to 10, but you use only up to 5.
I don't want you to read this all to me. I'm asking you why 2 and not just 1.
Because if you do 1, it's not even like actually makes sense.
That doesn't answer my question. Then why 2?
Because a lady used
Elaine?
2 samples of mix for each glass.
And what about Sandy?
She uses
The same? Different. She's using her lemonade mix differently than Sandy's using his lemonade glass. I know he because it's he. So are we connecting those 2 things or they're different?
they can sample too. That's what I think.
Why are you making 2 separate line plots? And why is she not doing anything that you're doing? That means you're not working nicely together. Stop, freeze, put your pencil down, and work nicely with her. All right, 512. we need some work on this. We'll continue to work on this. This was a challenging math problem, but that's the real goal of mathematicians, not just to look at a table and do times 2 times 2 times 2 because you feel like it, but to actually understand what you're doing in order to be a successful data analyzer. These graphs will keep coming up, Lewis. These graphs will keep coming up your whole life. Scientists use these graphs, mathematicians use these graphs. In social studies, we see these line graphs. You need to know how to read them, and you need to know how to make them. We'll continue to work on this. If you're not at your seat, please calmly go back.